In this video, we're going to learn how to balance redox reactions. There are two conditions in which you can balance redox reactions. You can balance them in acidic solutions and in basic solutions. So we're going to do this first video, we're going to do an example of balancing in acidic solutions. And then in the next video, we're going to do an example of balancing in basic solutions. You're going to see the steps are very similar for both. The basic solutions will essentially follow the same steps as acidic solutions with the addition of a few more steps to make it basic. So let's start with this example here. Balance the equation below using the half reactions method in acidic solutions. So there are many different methods for balancing equations, redox reactions. There's the oxidation number method and the half reaction method. In this video, we're going to learn about the half reactions method. So the first step here is to realize that we have acidic conditions. And once we realize that, we're going to take a look at our reaction here, and we're going to try to split it up into half reactions. We're going to do oxidation half reactions, and we're going to do reduction half reactions. For the first half reaction, we'll simply take the MnO4 minus A cubed. We're going to make our arrow here, and that becomes Mn2 plus A cubed. So we just took this and this, that's our first half reaction. And we're going to balance that first. We'll make our other half reaction after. We're just going to balance this one. It's under acidic conditions. A few things I want you to notice is that there's O on this side and there's no O here. First, I also want you to notice that the Mn has 1 here and the Mn over here is 1 as well. So our Mn is balanced. Typically when you're balancing acidic redox reactions, you want to balance anything non-O and non-H first. And so we look at our Mn, those are balanced already, so there's nothing we have to do there. Then afterwards we move on to the O's. There's 4 O's here, but there's no O's on this side. And so to balance the O's, what you do is you add water. You add as many waters as you need to get the number of O's that you need. So there's 4 O's, there's 1 oxygen per water, so we're going to add 4 waters. And this is not arbitrary. Keep in mind that this is happening in a solution. So in the solution, there actually is some water present, and so you're explaining that the oxygen is probably tied up in the water. So you always add your water so you can get the number of O's that you need. Next, you'll notice that you've introduced hydrogen. Well, now you have 8 hydrogens on this side that you didn't have before. So on the other side, you're going to add hydrogens in the form of H+. We have acidic conditions, H+. Now our last step is to make sure that we have our atoms balanced. So Mn is 1, Mn is 1, O is 4, 8 H's, 8 H's. We also have to make sure our charges are balanced. On this side, you have -1 and +8. That ends up being +7. On this side, you simply have +2. There's nothing else. So we have to bring this side down to 2. And the way we do that is we add electrons. So we're at 7. We're going to add 5 electrons, plus 5 electrons. Now that we've added 5 electrons, we are equal in terms of charges as well. And so from this we can tell that this was the reduction half reaction, meaning that this must be our oxidizing agent because it's receiving electrons. Okay, so our reduction half reaction has been balanced. Now we're going to go and try to balance the other half reaction. We'll do the Fe2 plus becomes Fe3 plus. So Fe2 plus aqueous becomes Fe3 plus. So first we're going to balance the non-oxygen and non-hydrogen atoms, and it looks like they're already balanced. Then we're going to balance the oxygens. There's no need because there's no oxygens on either side, and there's no hydrogens on either side either. So all that's left to balance is the charge. So we have 2 plus over here and 3 plus here. We need to make this 2 plus, so we'll add 1 electron. Now the goal is that we're going to add these up. And before we do that, let's just make sure we put this as the oxidation. And that means this is a reducing agent because it gave away electrons. So before we add these up, we have to make sure the number of electrons is the same for both reactions. Because if you gain 5, then the other part must have given up 5. So to do that, we're going to have to multiply one or both of the reactions so that the electrons are the same number. And so in this case here, we can multiply this half reaction over here, the oxidation half reaction, by 5. So we'll multiply that by 5. And when we do that, this becomes 5 Fe2 plus, 5 Fe3 plus, and then 5 electrons. So now I'm in a situation where I can add these together because the electrons will cancel out and the products, the reactants will just merge together. So MnO4 aqueous plus 5 Fe2 plus aqueous plus 8H plus aqueous produces 5 Fe3 plus aqueous plus 4H2O liquid plus, don't forget the Mn2 plus. So we're going to go and check our balancing. Let's see if our atoms are balanced. So 1 Mn, 1 Mn, 5 Fe's, 5 Fe's, those are balanced. 8 H's, 8 H's. Those are not oxidation numbers, by the way. These are just counting the atoms. And then over here we have 4 O's, 4 O's, that's balanced. Then we have to make sure our charges are balanced. So we have -1, and this is +10. So this is +10, +8, 18, so +17. Over here we have 15 plus 2, +17. So our atoms are balanced and our charges are balanced. That means that we balance this reaction correctly under acidic conditions. In the next video, we're going to take a look at how to balance reactions under basic conditions.